In this video, we're going to be finding the volume of two different shapes, right prisms and right cylinders. And as it turns out, we're going to use the exact same formula to do it. So let's make sure we understand what volume is. Volume is the amount of space contained inside a three-dimensional figure. And we talk about volume in terms of cubic units. So the reason why is that we're multiplying three dimensions together. And if we use this as an example, if we say our dimensions are in feet, then if we do feet times feet times feet, we get feet cubed, or feet raised to the third power. In order to find the volume of a prism or cylinder, we're going to use the exact same formula. It's just going to be our base area times the height. So I'll try and explain why that makes sense. If we look at this rectangular prism as an example, if we just find the area of our base shape, which is just a rectangle with dimensions 8 by 5, and then we fill up this prism with that two-dimensional area height amount of times, then that will give us the volume or the space inside this prism. So we could do that two different ways. One way to do it is to use the base area, and when we repeat it, it's called a cross section. And we could do it parallel to the base. So if we just stack them on top of each other, that's one way to do it. It is possible to do it perpendicular to the base. So we could use these side rectangles and fill up this shape horizontally. And we would be using cross sections that are perpendicular to the base. So that's also okay. But that's why we just use the base area and we multiply it by height amount of times, and it gives us the space inside a shape. So the base area is 8 times 5, 40 square feet, and we multiply that by our height, 3 feet, and we get the volume or the space inside. So 40 times 3 is 120. We did feet times feet to get the area two-dimensionally. If we multiply that by one more dimension of feet, feet squared times feet is feet cubed. So there's why we get our cubic units. We could do something similar with a triangular prism. Remember that the base shape of a triangular prism is a triangle. So if a triangular prism is not sitting on its base shapes, use the triangles anyways. You could always position it or rotate your piece of paper if you want to imagine that it's sitting on its base shape. Sometimes we may not have the dimensions that we need for the triangle. Like this example, we're given 13 and we're given 5. Well, to find the area of the triangle, we need that length right there. If you can recognize your special right triangles, there's two of them. There's a 3, 4, 5, and then there's also a 5, 12, 13. If you see side lengths in those ratios, hopefully you can just fill in the missing side length without having to use Pythagorean theorem to do it. But anytime you forget your special right triangles, you should be given 2 out of 3 sides of your triangle. Use Pythagorean theorem to find the third side. So now that we know that this is a 5, 12, 13 right triangle, we can find the area of the triangle by multiplying base times height. So 5 times 12 and dividing by 2. That gives us the area of the triangle to be 30 square meters. If we fill up this prism with 15 of those, that would give us the volume or the space inside. So 30 square meters times the height, 15 meters, gives us 450 cubic meters of volume. Let's talk about a cube next. So this is where the name of this exponent comes from. If we have a cubic prism or a square prism, a prism with a square base and the same length height, then all we need to do is multiply each of its dimensions by itself 3 times. So since all the dimensions are the same, we could just cube that value and take a little shortcut to find the volume. So because we have 3 dimensions that are exactly the same, that's where the cube name of the exponent of 3 comes from a cube shape. So we could do 3 cubed, which is 3 times 3 times 3, which is 27 cubic inches. We could also use that formula that we described initially, which was the base area times the height. The base area would be 3 times 3, or 9. And multiply that by our height of 3. 9 times 3 is still 27. So either way you do it, if you forget about the special cube formula, you can still use base area times height. This is also another place where algebra kind of takes off using radicals. So we can actually work this problem backwards. If we know the volume of a cube, we could solve for its side length by using what's called a cube root. So in the same way that we could find the side length of a square by square rooting its area, we could do the same thing with a cube. If we take its volume and cube root it, we get the side length of a cube. So a cube root is saying what number times itself 3 times is this volume. Well, 4 times 4 times 4 is 64. So this is what's known as a rational cube root. It's a nice whole number. Another way to think about radicals, which you'll do later on in algebra, higher levels of algebra, is use a fractional exponent. So this number right here on our radical is called an index. When you use a square root, it's just implied that there's a 2 there. We never write the 2. But when we have higher order roots, like cube roots or fourth roots or fifth roots or 100th root, we have to put our number there to indicate what type of root it is. So cube roots and beyond always include their index number right there. When we do it in a fractional exponent, the fractional exponent has 2 different things. It's got a power that's on top. So that's the exponent of the original number. This is 64 to the first power. On the bottom of that fractional exponent is the root. And if you think about plant roots are on the bottom, then hopefully that'll remind you to remember that the bottom of the fractional exponent is the root or the index value, the type of radical. So 64 to the 1/3 is also the cube root of 64. They're the same thing. Your calculator might be able to do this, or you could do it in this form. If you raise it to a fractional exponent, it should give you the same answer. So if we have rational cube roots, we could also have what are called irrational cube roots. And we could simplify them in radical form, or we could approximate them in decimal form. So in order to solve this problem, if we have the cube root of 54, in order to find the side length of this cube with a volume of 54 cubic inches, then we're trying to say what number times itself 3 times is 54. Well, there is no whole number that can do that. So we could approximate it. If you ask your calculator what the decimal value of the cube root of 54 is and round it, it's about 3.8. We could also simplify it in radical form, and here's how we do it. Let's break that number down into its prime factors. 54 can be broken down into 3 times 3 times 3 times 2. And since we're looking for a cube root, I missed a little cube right there, put a little 3 right there. If we're looking for cube roots of numbers, we're looking for triplets of multiples. So since we have a triple 3 here, we're allowed to take the 3 out of the radical and leave behind the 2. And there I got my cube root back. So this could be 3 times the cube root of 2, or approximately 3.8. And you could check your work. If I do 3 cubed, that's 27. If I do 4 cubed, that's 64. Well, the cube root of 54 must be somewhere in between 3 and 4. Well, it's about 3.8. All right. One more example. Let's find the volume of a cylinder. We could go back to that base area times height formula. We'll just find the area of the base of the circle and multiply it by height amount of times, and we'll get the volume or the space inside our cylinder. Since we're given the radius of our circle, we can find the area of the circle by squaring that. 8 squared times pi is 64 pi. Multiply that by the height. 64 times 16 is 1024 pi. And we could use a decimal approximation, multiply it by your decimal form of pi, and get about 3,217 cubic inches. So there's the volume of that cylinder. So the volume of any cylinder or prism is base area times height.